The purpose of this video is to provide a demonstration of each of Newton's three laws of motion to help you understand how the laws can be applied to real-life situations. For each demo, we will explain how one of the three laws of motion can be used to describe what you are seeing. Newton's first law states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. To demonstrate this law, we'll take a look at the physics of bowling. Initially, the ball and the pins are at rest. Because no force is being applied to them, they do not move. The ball and the pins are only set into motion once I pick up the ball and roll it into the pins. The unbalanced force that causes the ball to move is my hand that rolls it along the floor. The unbalanced force that makes the pins move is the ball, which rolls into the pins and knocks them over. In both cases, an unbalanced force causes the stationary objects to move, as stated in Newton's first law. If I hadn't rolled the ball into the pins, both the ball and the pins would remain at rest indefinitely unless some other force acted on them. If forces hadn't acted on the ball, causing it to stop moving, or on the pins, causing them to stop falling, they would have continued to do so.
Newton's second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force and inversely proportional to the mass of the object. In the example shown, I drop a pen and a full pencil case from approximately the same height. The pen and the pencil case have very different masses. The pencil case here has more mass than the pen, yet both objects hit the ground at the same time. This is because of the ratio of mass to force for each object is the same, meaning the rate of acceleration is also the same for both objects. This is because all objects have the same rate of acceleration when falling. This is due to the force of gravity. On Earth, this rate of acceleration is 9.8 meters per second squared, or 16 feet per second squared. As Newton's law states, an object's mass is directly proportional to its net force. The case has a greater mass, so it requires a greater force in order for it to reach its acceleration rate. On the other hand, the pen has a lower mass and requires less force in order to reach that rate of acceleration. The only time where this would not happen is if one of the objects was slowed down by air resistance, because air resistance tends to slow down most objects.
Newton's third law states that for every action, there is an equal and opposite reaction. In this demonstration, a ball is lifted up and then dropped. When the ball is dropped, it then bounces back up again one or more times. The ball exerts a force onto the ground. The ground will then produce an equal and opposite force to the ball. This is what causes a dropped ball to bounce.